Hello everyone, welcome back to the next video. In this video I will show you how you can do face detection using MediaPipe in native Android application. So let's get started. So first things first, I'm using XML layout. I'm not using Jetpack Compose, but feel free to use Jetpack Compose if you feel like. So here you can see that it is asking me for the camera permission first. I'll just give it the camera permission, and then here you can see it is able to detect my face. So I'll just move my face a little bit as well, so still it is able to detect it, and it also displays the percentage of confidence as well. So yeah, hopefully you got the point. We are doing it for live camera streaming, so it is not for a static image. I have already made a video about static image as well, so if you feel like, you can use that static image as well. And if I just move my face out of the camera, it is that particular bounding box disappears as well. So yeah, let's see how to do this in native Android. So firstly, what you need to do is you need to come to this particular documentation, scroll down, and at the time of me recording it, it only has this blaze face short range. So make sure you click on this and it will automatically download the TensorFlow Lite model for us. But in case if you want to by the time you guys are watching this video, if in case if this blaze face full range is available, make sure you download that as well. It is still coming soon. And for if you want to check this blaze face sparse as well, then you can check that as well, but it is still coming soon. So all you need to do is just replace the TensorFlow Lite model once this new models are available, nothing else. So make sure you download this particular blaze face short range. Like I said, I have created a native Android application using XML layout, and the first thing is you just need to create an assets folder. To create an assets folder, just right click, new folder, and assets folder, and then click on finish, and it will create an assets folder for you. Next, you just need to drag and drop this particular TensorFlow Lite model which you have just downloaded. So make sure you just drag and drop inside the assets folder. Don't create the assets folder manually, you will mess things up. Then inside Android manifest.xml, I have used this uses feature of Android hardware camera. Then you require the camera permission as well as the write external storage permission. And inside build.gradle.kts, I have added few dependencies. So first one is this MediaPipe task vision. Now don't use the one which is recommended by Android Studio. So if I just right click on it, here you can see it is telling me to use this 2023-0731. This is not the latest. The latest is 10.26. Now how do you find the latest? So for that you can just go to this GitHub repository of MediaPipe and just use this one, whatever is the latest. So this one was the latest at the time of me recording this video. Then here I have added this camera dependency, CameraX dependency as well, like the camera core, camera 2, camera life cycle, as well as camera view. Then you will see a sync now button. Just click on that sync now button and it will download the dependencies for you. Then what you need to do is just go to layout, activity underscore main.xml, and here you can see I have first taken a preview view. I have given it some ID. Then here we have width and height as 0 dp, and we are constraining it to all sides of the screen. Then here we have this overlay view. Now before you create this overlay view, you should create this overlay file. Now again, I have copy pasted this from the Android documentation. So the overlay view which you saw, this was basically that. So it is extending from this particular view class to draw that bounding box. So I'm not going to go through the details of it, but yeah, you can just copy paste it. Like there is nothing only thing is here you need to define a color for your bounding box, and I've defined it inside colors.xml over here. Okay, so yeah, that's the only thing. Rest you can just copy paste it. So if you want to give it some different color, you can give it some different color as. And this was the detection category name which we were the score, right? The score which we were displaying, sorry. And here, yeah, we are just drawing the bounding box over here, and we are just drawing the text over as well over here. Then here we are setting the results, and yeah, this is just a companion object. Now you can just create this overlay view, but make sure you use your own package name. So don't use my package name. So just type overlay view and it will automatically give you the entire thing. Okay, and here I have done the same thing, width, height 0, and constraining it to all sides of the screen. Okay, then what I have done is we have created another Kotlin file called face detector helper. Again, I have copy pasted it from the MediaPipe documentation. So firstly, these are all the imports. So here we pass it the threshold, delegate, running mode, context, as well as face detector listener. So here is our face detector from the MediaPipe. Here we call setup face detector. This is a method for clearing face detection. So inside setup phase detector, we just use these base options, and here you can define whether you want to use CPU or GPU. Here make sure you use the same name what you have for your TensorFlow Lite model inside the assets folder. So in case if you decide to rename it, make sure you change it over here as well. Then we use this base option builder.set model asset path. Then here is the running mode, so we are using the live stream one. Okay, and if you want to use image or video, you can use that, but you'll have to change the method as well. I'll show you that method. We have it for image as well. I'm not sure about video. I think we don't have it for video, but let's see. I have copy pasted it. So here we just initialize phase detector options.builder. We set the base option, we set the min detection confidence as well as the running mode, and here depending on, for image and video we just do set running mode, and for live stream we have to set the result listener as well as error listener as well. Then we do options builder.build, then we initialize our phase detector, and these are for handling any catch exceptions clauses as well. Then inside is closed, we just say if phase detector is equal to null. This is for detecting video file. Here you can see I'm not really using it, so in case if you have a video file, you can use that as well. Do let me know in the comments if you would like to see a video for that. So again, I'll simply scroll through this, like we are not really using this particular thing, but if you want, you can refer to the MediaPipe documentation from where I have copied this code. Okay, then this is for detect live stream frame. So this is what we are using. So we get an image proxy, from that we get this get the frame time. I think we can simplify this, so you can directly use create bitmap, pass the width and height of your image proxy. Then here we just do this byte buffer dot copy pixels from buffer, then we close our image proxy, then we do matrix dot apply, we rotate it and we scale it as well. Then here is our rotated bitmap. Then here we do bitmap image builder, passing our rotated bitmap, calling the build, and here we call detect async. So here we just do phase detector dot detect async, passing the MP image as well as the frame time, and this is the return live stream result. So again we get our frame time milliseconds, inference time, and whatever is the result we just send it back to the main activity in which we will be implementing this listener. And here we send back the error in case if there is any error. Now this is used for detecting image. Again, we are not really doing detection of image, so again I'll simply scroll through this. If you want the code for image, you can use that. And this is the result bundle which we are sending it with the help of the listener, and these are companion objects which I have defined. Okay, and this is the interface for implementing on error as well as an on results. Now the last thing is we just need to go to main activity over here. So firstly I'll show you guys all the imports. So there are a lot of imports, so yeah, feel free to copy it. I don't require this dead import, so I can just remove it. Then here we have this phase detector helper dot detector listener. So this will, for this we need to override two methods which I will show you shortly. Then here we have this phase detector helper, this preview view for CameraX, image analyzer, camera provider, background executor as well. Here we set the delegate. If you, I have not tried with GPU, if you want you can try it. I'm not sure if all Android devices supports GPU or not. Then here we define the threshold. I have kept it as the default threshold. You can play around with the threshold as well. Then is the camera preview view, and this is the overlay view. This is a register for activity, just to check whether we have the required permissions or not. If we don't have it, we just display a toast message. If we have it, then we just call setup camera. Then inside on create, we just initialize our viewfinder, we initialize our overlay view. Then here initialize our background executor as well. Then inside background executor dot execute, we initialize our phase detector helper as well. And if all camera permissions are granted, then we call setup camera, else we call request permission. Then inside on resume, we do background executor dot execute. If phase detector helper dot is closed, then we just call setup phase detector. And inside on pause, if it is not initialized, then we just call execute clear phase detector. Inside on destroy, we just shut down our background executor as well. Then inside setup camera, first get hold of our camera provider future, we add a listener. Then we get our camera provider, we bind our camera use cases as well. Then here is our aspect ratio strategy. Here is our resolution selector as well. Then here we get hold of our camera provider. Then this is the camera selector. So here we pass the front facing lens. Then here we initialize the preview view as well. Then here we initialize our image analyzer. So here you can see we pass the resolution selector, target rotation, back pressure strategy, output image format. and then we just do set analyzer, passing in our background executor as well as this detect live stream frame method which we have from face detector helper. Then we unbind our camera provider, we bind it to the life cycle over here, make sure you pass the image analyzer as well, and finally set the surface provider. Then inside on configuration changed, we change the target rotation based on the viewfinder rotation. In case of error, I'm just logging into the console, but yeah, maybe you can handle it differently. Then inside on results, we just do results bundle dot results, and then do overlay dot set results, get the detection results, pass the input image height as well as width. Then here we have this request permission method as well, and here we have another method called all permissions granted, and here you don't require this first two variables, you can remove this. And here I just have a companion object, so we always require camera permission, but if you are using Android less than equal to P, then we require write external storage permission as well. So yeah, that's all there is to it. Thank you for watching. Bye.